one of the best ways to learn new tech is by getting hands-on. And what is one of the best ways to get hands-on? Well, by building projects. And this is also one of the questions that I get asked the most from professionals and students is like, hey, Rishabh, I'm learning Azure or I'm learning XYZ cloud certification. What project should I build? And I personally have dealt with this issue of coming up with good project ideas, trust me. And to help with that, I've built something. What you're looking at is my very basic LangChain app. And let me show you what it does. So if I open up my terminal here, bear with me as I run this script, which is called starter.py by typing in Python starter.py, hit enter. We wait for some AI magic to happen, and hopefully we'll get a response soon. And there we go. So in the response, it says, sure, here are a few project ideas for Easy 104 exam, implementing Azure virtual machines. And you can go through the entire response, which I don't feel so confident about looking at some of the things in here. But let me show you what I created by looking at this code file, which is starter.py. So it's a basic LangChain application. As you can see on top, I'm importing LangChain OpenAI because that's what I'm using as the model. And I'm doing a simple query saying that, hey, can you help me with a project idea for Easy 104? And you might be saying, hey, Rishabh, like, how is this different to asking ChatGPT in my browser? And you're right, this is not that different. But this is code, and this is LangChain and Python. So we can take it a step further, and I'll show you what I mean by that. So in my browser, as you can see, I have this cool Streamlit app, and shout out to Kadesha if you saw her session, she was using Streamlit. Streamlit lets you build, cool front ends using Python. So what I have built is a cloud homework app. And let me zoom in for better visibility. But you can see you have the ability to pick an Azure certification. I picked Easy 104. You pick project level, so it can be beginner, intermediate, or advanced, depending on where you are in your journey. And you can see the output is way better than was in our terminal. So it is an Azure storage, file sharing monitoring with services listed. And what I like is all the steps that I need to build this project. And that's where LangChain comes in and helps us. So today, we will be exploring what is LangChain. And we'll learn about how we can leverage LangChain specifically with the Azure AI Services. So since this will be a hands-on workshop, so you can follow along with me. I'll try to pace it up because I only have limited time, but you can, again, watch this on demand later. Since we'll be building an LLM-powered application, there are some prerequisites that you need to follow along. One of them is Python, no doubt. I'm a huge Python fan, so don't come at me, JavaScript developers, but you'll need Python 3.9 or any higher versions. And you also need a Python package manager. I'll be using pip today. The next thing that you would need is a code editor. And I'll be using Visual Studio Code. And the last thing that we are left with is an OpenAI account, because we'll be using OpenAI's API to interact with their large language models. Again, you can use any other models that are available from Hugging Face. I just heard Phi 3 is out from Microsoft, so go try that out. Awesome. So now that prerequisites are out of the way, let's move on to what is LangChain. So it's an open source framework that allows you to build large language model applications by bringing in your own computation and data. And you'll see what I mean by that. But majorly, it focuses on composition and modularity. The framework currently is offered in Python and JavaScript, but there's a lot to unpack with LangChain. And new stuff is being added to the framework every day. So I personally cannot keep up with it, even though I build with it daily. But on a high level, this is what the framework looks like. So you have models, which are basically your large language models. Again, this can be GPT 3.5, GPT-4, or the open source ones from Hugging Face. You have prompts that allows you to set instructions to guide the response from your large language models. You have chains, which allow us to combine multiple components within this framework to perform a specific task or action. And then we have indexes. Indexes allow us to extract relevant information for our LLMs. Finally, we have agents, which I won't be touching too much base on, but it basically allows the large language models to use external APIs to perform a task. Now, let's look at these components in action. OK, so I'm back in my Visual Studio Code. And before anyone in chat wonders what my theme is, it's Deep Dark Material, I think. But let's copy this basic app. So I had the basic LLM invocation here. I'm going to copy it. I have another app called AI.py, again, named appropriately. And I'm going to paste it. So just to go over what's happening on top is a bunch of inputs. So I'm using OpenAI's large language model. We already know that. So that's going to be our LLM. And you can see the second concept we saw on that slide was prompts. And that's where I'll be using the prompt template. And I'm loading the environment variables from a .env file. And that's where .env library helps us within Python. So right now, I have a function called askLLM. So I'm going to rename this to something more appropriate, like project idea. And then also, we can get rid of the query argument within our function, because we'll need some other arguments to work with, depending on what we want the users to select, right? So the first concept within the slide we saw was models. And this is basically that. So I am initializing an OpenAI model here, specifically chat. And if I type in just OpenAI, it defaults to GPT 3.5 Turbo. Or you can specify it by typing in model is equal to whichever OpenAI model you want to use. I'm going to stick with GPT 3.5 Turbo, and that covers our first concept. The second concept was prompts. So let's see it in action. So I can initiate a prompt template by typing in prompt template. And there are two things that I specifically need within my prompt template. The first one is input variables. And we'll see them in action just after I get a working prompt template here. So I got the quotes right. And also, I'll need a template. And as you can see, I have, can you help me with a project idea for AZ104? This is good, but this is also where your prompt engineering skills come in handy. I'm going to do a little bit of cheating. And I have a really good prompt that I engineered in my README. So let me open that up real quick, copy my prompt template right here, and go into our file and paste it within our template file. There we go. I think I have two quotes. Yes. And that should fix this. So there we go. It says you're a helpful cloud instructor that provides cloud project ideas about Microsoft Azure certifications based on certification guide. Give me project idea for a certification. So the idea is I want the user only to have the ability to pick a certification and a level. So certification can be AZ104 or AZ204, 305. There are a lot to cover. But I also want them to pick a level of the project. It can be beginner, it can be intermediate, or advanced. So you see how here you have those mustache brackets or curly brackets. That's where the input variables will take in. So these can change based on user input. So I'm going to say for input variable, we'll be using certification as 1 and level as the second input variable. And there we go. So we have covered our second concept, which was the prompt templates. I feel pretty happy about this. And now comes the third point on that slide, if you remember, was chains that allows us to combine multiple components within LangChain. So let's initialize a chain by typing in chain. Again, you can name this appropriately. I'm just going to go with chain. And as I said, the framework itself changes a lot. And that's where LangChain expression comes in. Earlier, the statement used to look a bit more complex, but now it's as simple as LLM, because that's where our model is, and prompt. So I'm just going to pipe that. And that's it. That's how you create a chain within LangChain right now. So instead of doing an invoke on the LLM itself, I'm going to do a chain.invoke. And since we are not using query as the argument in our function, as you can see here, we got rid of that. We'll have to have certification and level. So let's go back to our function on top, add an argument of certification and level. And we'll map those here to our invoke. So how you can do that is by saying certification from our argument is certification within our input variable, and pass the value of level from our function argument to the input variable for our large language model. And we can also get rid of this print statement since we won't be invoking the large language model directly and using Streamlit to run this chain. Now, what you might have seen in the prompt template is by searching the following certification guide, and there's an input variable called docs. And I didn't talk about it. So let's go back to our slides. And this is where the fourth concept, indexes, come in. So we know that these large language models are trained on unstructured and unlabeled data. And the best way to store this unstructured data is vector stores. So one of the most common ways is to have a vector store like Azure AI Search, which I'll be using today, is to store the unstructured data, embed it, and store the resulting embedding as vector representation. I know there's a lot to unpack here, but if you watched Pamela's session on RAG, you know what I'm talking about. So to build this custom knowledge base, what we'll do is use certification guides. And that's where these documents come in, and this cool diagram depicts how we are going to use this chunking method. So the documents will be the study guides, the official Microsoft study guides around the AZ-104, 204 certifications. We'll chunk them into smaller documents, and those documents will be stored as embeddings in a vector store, specifically Azure AI Search. So let's go ahead and build that. OK, so I'm going to save the current state of my ai.py file. And let me make sure I have paused my slideshow so you can see my VS Code window. So I just saved my ai.py. I'm going to go ahead to knowledgebase.py, again, using very good names for my files here. So there's a lot of stuff already happening in this file. And I'll go over very quickly that I'll be using Azure AI Search, so I'm importing it from the LangChain community. And you can tell there are a lot of helper libraries available within LangChain. And then you also have OpenAI embeddings. So I love OpenAI embeddings model, so I'll be using that for my embeddings. And I have a corrector text splitter built within LangChain that I'm importing, along with an unstructured URL loader. What we'll use that for is to load these URLs, because this is where the certification guides exist. So these are Microsoft Learn URLs, and you can see AZ-104, 204, 305, and 400. Those are the 4 certifications that I'm working with today. And since I have some sensitive information about my Azure AI search, I have stored them in environment variables, and I'm just bringing that in here. So now let's initialize our connection to Azure AI Search. And I'll be storing that in vector_store here. So vector_store will initialize Azure Search. And there are a few things you need to pass to make that connection. So the first one is the vector store address, right? So you have to have an endpoint, and the Azure Search endpoint is my variable called vector store address. So I'm going to copy this, paste it here. Same thing for the Azure Search admin key, and that is the vector store password in my variable. And there's some indentation issues. OK, now we also have to specify the index name. So I've already created this index, which is empty right now, called LangChain vector demo. So index name is equal to index name, and an embeddings function. So embeddings_function, since I told you we'll be using OpenAI's embeddings model. So embeddings.embeddQuery is what we'll be using today. And that's basically our connection to Azure AI Search. Let's get rid of some white spaces in here. Now, we have those connections. Now we have to chunk our study guides. So in order to chunk our study guides, I'll be using the text splitter. But first, I have to load these URLs. So I'll be using a loader, right, which was the unstructured URL loader. And the list of URLs is called URLs. Very handy. Now, I'll save this as documents. So I'll create a documents variable and load these URLs. There we go. Now, since I'll be using the corrector text splitter, let's initiate that. I do want to specify some settings, again, because these large language models do have token limits. And I can only pass certain amount of information into the prompt. So I'll have to specify a chunk size. And instead of 5,000, I'll go with 2,000. And for the overlap, I'll go with 200. And what does that mean? So we'll have a huge study guide. We'll break down into smaller documents, as we saw in the diagram on slides. Now what happens is, what I want is the first chunk, or the first smaller document that was created, I want some overlapping on the next document so that the context is not lost when we do some kind of search on this vector store. So that's what's happening in this line of code. And now we'll save this in docs using our text splitter.split documents. And documents are called documents, so that comes in handy. There we go. OK, so our chunking will be handled here. Now we have to save this to our vector store. And you can do that by vector_store and add documents. Oops, store.add documents. And the documents to be added are called docs. So there we go. We have that ready. Now, the next concept comes in of similarity search. And Pamela's session was amazing about another key term called RAG. You will see that. But there are different types of searches you can perform. And today, I'll be using similarity search. And it also talked about, I think, hybrid search. So in order to perform a similarity search, we can do vector_store.search. And let's go with query to be Azure Administrator. I think that's a good certification. OK, let's go with just Azure Administrator. And instead of, OK, I think I'm good with k is equal to 3, which basically means it'll return 3 documents. And since we'll be using similarity search, let's specify that. So it will be similarity_search. Now I can save this and do a print on docs. So let's open up our terminal here, and let's clear the screen and type in Python knowledgebase.py. OK, so we did get an error that says the Azure search key is missing. So instead of admin, this needs to be just search key. Let's see if that fixes it. So again, I'll be running Python knowledgebase.py. Hit enter. And let's wait for, OK, it's doing something. There we go. So if I scroll up, you'll see that there are 3 documents that were returned. So as you can see, this is the document 1. And this is all from our study guides. So it says page content, skill measured prior to October 26, audience profile. So I can already tell by looking at this, this is from the official study guide because I'm a huge fan of cloud certifications. And it returned those 3 documents. Now, let's bring these docs into our AI.py. But since most of the code for connection to Azure AI Search is already written within our knowledgebase.py, so I'm just going to copy that. So the settings and the connection to Azure AI Search, I can go up top here and do a paste within my AI.py. And now let's go ahead within our project idea and implement that similarity search. So let's go ahead and pick this line of code from our knowledge base, go back to the function. And before we initialize LLM, let's paste the docs line. So instead of hard coding Azure Administrator, I want the user to pick the certification. So what I'm going to do is use the certification argument from our function right here. And one key thing to remember is it'll return 3 docs. So what I want to do is join them and send it over to our large language model. So let's do a join here. And space dot join. Help me join these 3 docs. So if I look in my terminal, the content that we were looking for is called page_content. Because there was additional information about our chunk that was returned, and we don't want that to, confuse our large language model. So we only just want the study guide content. So that's what's happening here. Now the only thing is left is to include docs as an input variable and make sure we have that as the mapping in our chain.invoke. There we go. So I feel pretty confident about our AI application here. But before I dive into this, you might be able to map this to a concept you might have heard of if you're active in the AI and ML space. And that is RAG. So RAG stands for retrieval augmented generation, right? But basically, it's the process of fine-tuning your model without having to retrain the entire model. So what you're doing with RAG is you're passing relevant information. In our case, it will be the certification guides, right? And you don't have to train the entire GPT model again, but you're telling, hey, here are certification guides. Make sure you use them to provide an answer, which basically makes our project idea better than what we were doing earlier. And this basically allows you to build a large language model applications that follows this kind of pipeline. So the user comes in our case, let me turn on my laser pointer. So the user comes in, it says, hey, I need AZ104 cloud project idea. That information is passed to large language model, but it also is used to do a similarity search on our vector store. The similarity search says, OK, here's the study guides for AZ104, which acts as the relevant information. This relevant information, along with the request from the user about AZ104, is passed on to our large language model, which basically ends up resulting to a good response. This entire pipeline kind of acts as RAG. So let's go ahead and test it. So now let me go to streamlit.py, and on top here, what I'm going to do is import AI as AI, because we named our file ai.py. You can see that there are two variables, certification and level, which are Streamlit select boxes between certifications and project level. Those certifications are on level if those variables are set. I use the project idea function to generate the project idea. So now let's run this Streamlit application by opening my terminal here. Let me clear this out for you. There we go. And now we can do Python, Streamlit. Streamlit run streamlit.py. There we go. Hit enter, and it should open up import AI as AI. So it should open up a browser window. Let me make this bigger. There we go. And let's look at the error message. So it says that something is wrong with the AI file. OK, let's go back to our code editor, go into ai.py. It said that embeddings, it doesn't know what to do with this. That's because I never initiated embeddings in here. That was only in our knowledge base. So let's fix that quickly by initializing OpenAI embeddings. And let's see if we can just refresh our page in the browser and it will work. Oh, looks like it's working. OK, now we have another error that says that the prompt template, there's an issue with the validator within our input variables. Let's go look at that. This is all the fun about doing a live demo, right? We'll try to fix it. OK, so input variables, see, a simple S is missing from input variables. And now let's go ahead and try that again. Third time is a charm, right? OK, nope, it is not. I think I have to restart my file here. Let's go back. Control-C in my terminal, and then type in Streamlit. Make sure I've saved this file. OK, yes, it is saved. And Streamlit, run streamlit.py. Let's refresh it. Nope. So must be a prompt value string or list of base messages. Let's see what's going on. Chain.invoke, OK. Certification level is set to level, and docs is set to doc. Everything looks, I think it's not giving me the correct error. Let's look in our terminal to see what's going on. So invalid input type, class dictionary must be a prompt value string or list of base messages. Am I passing the input variables wrong? Let's see. So chain.invoke looks good. The mapping looks OK. We have those set as arguments within our function. Let's try. Oh, I see what it is. It's a type dictionary. I just need 2 round brackets. And this should work now. Nope. OK, let's restart it. Let's retrust it. Control-C. Make sure I've saved it. Yes, I've saved it. Hit enter. Nope. It still is erroring out. So something is wrong with my input variables. I hope that something was not changed on the LangChain side of the framework. But let's look at what's going on with input variables. No, it seems right. Okay. So yeah, I'll have to check LangChain documentation on what's wrong, but I'm quickly going to show you what the RAG pipeline builds, right? So this entire diagram basically translates to this, right? Because you have your certification that you can pick from the Streamlit app, so AZ204, intermediate level, and it'll generate a project idea using the study guides. And the possibilities are endless with LangChain and Azure AI. I just can't wait to see what you build by leveraging today's demo and building your own RAG pipelines. But yeah, that was today's session. I do have a QR code for you to connect with me and also ask me any questions if you have. So you can find me on Twitter, LinkedIn at RishabinCloud. And I do have a QR code. It'll be up. There you go. So yeah, connect with me. Ask me if you have any questions, and I'll try to figure out what's wrong with my LangChain app.